She holds a doctorate and a master's degree in public health from Columbia University and a BA in English from Wesleyan. Her dedication to environmental health stems from her belief that the health of the ecosystem and that of those who live in it are inextricable. We cannot live on a planet we pollute, and we wouldn't want to anyway. So please enjoy this presentation on microplastics, plastics, and health. Dr. Wolff. Okay.
Thank you. It's great to be here. I came in from upstate New York. I once heard somebody say the definition of an expert in Bozeman or Montana is someone from more than 100 miles away. So, woo, I'm officially an expert, and I don't know where to go. Put that on the ground. When my parents were here in Bozeman, so I spent a lot of time here, and I absolutely love coming here, even when it means I'm here to just scare the pants off of people about plastic pollution, which is kind of what I do. I'm the executive director of an organization called PSNAP, which is the Physician and Scientist Network addressing plastics and health. And so I network healthcare personnel. Physician is just an umbrella term we use to scare conference people, but healthcare personnel in general are highly regarded. Even in our very partisan society, our voices are loud. And so healthcare personnel speaking on climate, on plastics, on any number of environmental health issues are heard more than most other people in the room. I have actually seen that firefighters are heard even more, and I'm curious about that. But in any case, that's what I do. So we're communications people, and I try to keep it lively, scary and funny. I don't know, it's always scary, but this is housekeeping. Those of you who are getting continuing education credits, now you've seen this. So my background, I did my graduate work at Columbia, and actually I studied the history of public health and medicine. I was trying to figure out, how did things get this screwed up? By that I meant, we have this fantastic healthcare system, except nobody can access it or pay for it. So what happened there? And it turns out, well, if you study how we got here, you can figure out maybe what comes next. And from that, you get a bunch of lessons. And one of the key ones is that history is not inevitable. There's not a passive voice in history. Mistakes were not made. People make decisions, specific individual people, and they make them based on very specific events at specific times. And so as you look backward, you can unravel those, you can create accountability, but you can also find ways to move forward, which I think is particularly important in the climate fight, where it's so easy to feel totally overwhelmed. And how do we find our way forward? Problems that are not inevitable are solvable. Problems that we created are not inevitable, and therefore they're solvable. And that's the hope that I carry forward in all of this work, no matter how dark it gets. And yeah, it gets really dark. These problems, they seem insurmountable, but they're relatively new. Historically speaking, especially plastics, are very new. And okay. Oh no, virtual people, sorry about that. Anyway, so the plastics problem, we really only had plastics as we know them today since about World War II. And my mother was born in World War II. So that's a life, that's a single lifespan. That got us into what we consider the mess we're in today. And that actually gives me a lot of hope, because people who are alive today remember things differently. And one of the things that we know is that whatever things were like when we were young is how we kind of think things are supposed to be going forward. So those of us who are older in the room remember a very different climate than the one today. And that is useful to keep thinking about that. I'm just gonna, okay, we're good? All right, I'll roll forward through a couple slides here. Am I on? How do I throw? Oh, yeah, now there's a disjunction. So is this the Zoom screen? Well, I can vamp to the crowd a little bit, actually. I was curious about who's in this room. If you're a healthcare practitioner, hands up. All right, are you healthcare administration or healthcare not otherwise specified, hands up? Okay, climate advocacy people? I guess the Venn diagram there is like the same, we're all in this room for a reason. Okay, That's cool to know. I was thinking practically everybody in this room is PSNAP eligible. We have lots of pharmacists, we have lots of nurses, we have lots of pretty much everybody. Because interdisciplinarity is the way to go. It looks like we're not set yet with this. I'll just I'll just keep talking. I actually cut my teeth as a walking tour guide in New York City. So like if you wanna, drive a truck across the room or something, I should be all right. Okay, it should be all right anyway. Oh, I always need to say at the beginning of my plastics lectures, because we're all, ooh, I don't know what just happened there. Hi, I'm not seeing my own presentation anymore. You're seeing my presentation, I'm not. The plastics issue, very much like the climate issue, it's easy to feel implicated. I mean, Americans especially use and throw away massive quantities of plastic. But this is a structural and systemic problem. You did not individually create this problem. You are not individually going to solve it. So you can check your guilt at the door right there. We're a part of this, but we didn't cause it. Together, we can solve it though, and we will. I actually really do think we will. So another preliminary piece of housekeeping here, I just want to point out that I'm not a plastics abolitionist, and my org is not a plastics abolitionist org either. While we see incredibly important and significant problems with the material, if you were a doctor in, say, 1845, you would be working with the tools on, I guess that's your right? Yeah, your right, my left. I wouldn't want to be a patient at that time, right? If you go over to Bozeman Deaconess, you're going to see a lot more of what's on the right, and I would much rather have that the next time I, fall out of a hammock or whatever it is that I do that lands me at Bozeman Deaconess. So a lot of the plastics that we use in our lives, some of them really are necessary. They could be reformulated. We could reduce their use. But I'm not here to slam all plastics. I'm here to slam the way that we have been utilizing plastic on a mass scale without thinking much about what it's made of, what it does, and what it costs us beyond that initial use. Well, the problem with plastics, as most people see it right now, is volume. We've made more than 10 billion tons of plastic since 1950, and almost none of it has gone away. There was a seminal article, I think in the 20-teens, called The Fate of All Plastic Ever Made, by Jenna Jambeck and Roland Geyer. And if you're in this tiny little sphere that is my field, it shook the field, because guess what? It's all still here, except the plastic that was incinerated, which is now dioxins and other really friendly airborne chemicals. It's all still here because it doesn't break down. It breaks up into tiny particles, but otherwise it's still with us. And there's a very active discussion going on with particle chemists and, polymer chemists on, when does plastic stop being plastic? Is there ever a point where it mineralizes and starts going back to its elements? The jury is out. So it is still with us. From my perspective, though, and most of the people who study plastics and health and environmental health, it's not just a problem of volume at all. It's a problem of ingredients and makeup, because plastic is a chemical product. 70% of the synthetic chemical industry goes into plastic. That's a lot of plastic. We manufacture 10 times more plastic annually than pesticides. Pesticides, we think about what they could do. Plastics, not so much. The majority of them are untested. The ingredients are unknown. There's chronic universal human exposure. So we're actually exposed disproportionately. The rest of the ecosystem is a little bit better off than we are. But if we look around at our built environments, most of it's plastic, from the polyurethane on this wooden floor to the chairs to the fibers in my sweater. It's plastic everywhere. So we are absolutely surrounded by this. It's received virtually no attention from EPA. One thing I want to draw a little bit of attention to before the next slide here is this timeline. All right, well, we are around here. 1962 is when the book Silent Spring came out. Raise your hand if you're familiar with Silent Spring. Yeah, that was when books were still the way that we got a lot of our information. So Rachel Carson authored that, looking at the deluge of synthetic chemicals that were going into the environment and how they were impacting nature. And she's, she's looking at birds, she's looking at a lot of things, and she's focusing on pesticides, but on a comparative scale, that's Rachel Carson right in there. We're over here, and we're heading over here. That's a pretty significant scale. So that keeps me up at night. Next slide. Hello, slide. There we go. Now, from Carson's point of view, the problem was really one of scale. For us, it was the quantity that we were pumping out there, but it was also the amount of time. Just as given time not in years, but in millennia, life adjusts and a balance has been reached. For time is an essential ingredient, but in the modern world, there is no time. It's coming faster than we can adjust to it. And this is a much more modern schematic of kind of the same idea. This is the planetary boundaries schematic that was innovated also in the 19-teens, updated to 2023. And each time we surpass basically an area beyond which we've used more resources, we cannot function safely as a species, we move into the red. You'll see that novel entities are actually the furthest out there, and novel entities are synthetic chemicals. So how many do we have? We have absolutely no idea. There are 350,000 of them that have been registered for global production, but of those 350,000, at least 50,000 are confidential. They're trade secrets. We don't know anything about what they are or what they do. 70,000 of them are ambiguously described, so it's the same thing. We really don't know what they are or what they do. And how many have been studied? Just shout out. How many do you think have been studied? 0. The cynics over there, the optimists over there, 1,000, okay, 3,500. But of that 3,500, we only really understand the large scale environmental impacts of 65 of those. So that's what we're worried about over in plastics land. It's not just about detergent bottles bobbing around in the water or this, although this is horrifying. Absolutely horrifying. None of us want to see this, and yet all of us do, all over the world. And here's where it gets even happier, right? In 2005, a guy named Richard Thompson, who was an oceanographer, coined the term microplastic, which by now we've all heard. It's like dumpster fire. It's one of those just common terms in our language. And a microplastic is any little bit of plastic that's the size of a pencil eraser on down. So it can look like sand, it can look like a grain of salt, it can look like a pencil eraser, which by the way is made out of plastic. So yeah, but the thing about microplastics is that they just keep getting smaller and they fragment down into nanoplastics. And to make this kind of clear what we're thinking of here, so we have over on this side of the slide with microplastics, pencil tips, salt, and here at the bottom, those of you who think about air pollution, who are pediatricians, who are thinking about fetal development, we've got inhalable on microplastic. That's not fun. We don't love inhaling microplastic, but we are at least evolutionarily adapted to cough out larger particles, which is what we do with most of this microplastic. It's when you get further over on the slide that we start to really worry. And we started to really worry a few years ago as we started realizing just how small microplastics can get, because they can get down to the size of a particle of smoke. Now, Lori had that slide up earlier about PM 2.5 and air pollution and its impacts on fetal development, fetal health, child health. We're seeing a lot of the same impacts as we study plastics too. The Venn diagram here is highly overlapping, and some of that we know is about delivery, because we've got plenty of nanoplastic that's the size of a particle of smoke, but then also could be the size of a COVID virus or the width of a strand of DNA. This is like hard to conceptualize things this small, but once you get down that small, no matter what, you're looking at things that are respirable. So they're passing through the alveoli of the lung and into the bloodstream and moving around in organs. And they're also passing across the intestinal lining and into the bloodstream and moving around into organs there. And that's the point at which most people start to hyperventilate a little bit and say, okay, what does that mean for us then? Well, it means, yeah, we're taking in some microplastic, and here are the main mechanisms by which we're doing it. We're inhaling it, yes, we're ingesting it, because it's in the water, it's in the food. Everywhere that investigators have ever looked for micro and nanoplastics, they have found them, from the top of the Himalayas to the bottom of the Mariana Trench. So, okay, it's in the food and the air. It also does cross the skin, not usually as plastic particles, but those chemicals, because plastics are made of chemicals, they will cross through the skin, especially while you're sweating or if you have high contact. So maybe not so much with the microfiber sheets. Flannel's really nice, I promise. There was a statistic that came out a few years ago from the University of Newcastle where they said that some people under some circumstances may be ingesting as much as a credit card a week of plastic. Now you'll hear there's a lot of qualifiers in that, except that most of what we really hear is a credit card a week of plastic. And that certainly got a lot of attention. The press really loved that one. And it resulted in an awful lot of gallows humor, which is kind of where we are with a lot of this all over the internet. The memes were hilarious, frankly. Microplastic spices. I love the food pyramid for 2030 with antidepressants at the top and microplastics at the bottom. And this is a Reddit comment. I eat a credit card every Sunday. Just get it out of the way. Have a nice plastic-free week, right? So, all right, this is how we handle what we can't control. But we also keep asking questions. Like, where are they? If they're in our bodies, what's happening? Well, we pass a lot of the actual microplastic, the stuff that's large enough for us to pass. We do, but some of it does remain in our bodies. And among the first places that it really got a lot of attention was this January 2021 publication, finding it in the placenta. And it was on both sides, the fetal and the maternal side. And part of the reason that this got as much attention as it did is that the placenta is thought of as an impermeable barrier. It's safety for the fetus, and the fetus is the future. So this is quite upsetting across lots of levels of society. It didn't kick off this search for the microplastics, but it certainly fueled the race to research, which had been going since about 2018 when they were found in human feces. There's the placenta, the lung. And as you can see here, it just keeps on moving. Breast milk, blood, liver, urine, veins, testes and semen. That got a lot of attention too, some of it for obvious reasons. The slightly less obvious reason is that the testicular barrier is another place that we didn't think that microplastics would cross. That's supposed to be another inviolate barrier. And there's one more barrier that we like to think nothing is ever going to get through. And I'll give you a hint. It's above my neck. Anybody want to take a stab at what that is? Yeah, so is it crossing the blood-brain barrier? Yeah, you guys have news feeds. Okay, kidneys, carotid, there it is, the brain. May 2024, that broke the internet. Olfactory bulb, bone, follicular fluid, and on it goes. So what does it mean? That's what we really want to know. Well, most of what we have at this point, actually we have quite a lot. We've got animal studies, we've got lab studies, we've got the animal models in vivo, the in vitro models in the lab, so we know what happens when you put most of these chemicals or even particles next to cells. They fail, which is a word for die. And in the lab, the animal models don't do very well. And usually the animal models preclude the human models. So what happens in them happens in us. But we didn't really have the human models until recently. And of course, anyone trained at any level of ethics knows that you can't just, go up to a human being and say, okay, I'm going to give you all this microplastic. Now I'm going to inject you with some stuff and you're just going to die and now I'll dissect you and we'll see what happened, right? So there goes that level of certainty. But what we have in the interim is a lot of people who are exposed, who may have a lot of microplastics in their bodies, and we can see how they're doing. So correlative studies. These are starting to come out, and this was the first one that really kind of got a lot of credible attention worldwide. It came out in the New England Journal of Medicine in 2024. That's beyond like the threshold of any kind of accountability. Like, by the time it's in New England Journal of Medicine, it is highly vetted. This was a group of investigators who looked at 312 patients who had blocked carotid arteries. And so they had that ablated, they had the plaque taken out, and then the investigators looked at the plaque. And they found that in 58% of the patients, they found micro and nanoplastics in the plaque. And then they followed all the patients forward for 36 months. And I should blow up this piece of the slide because this is really the money shot. The patients with the micro and nanoplastics in their plaques had a 350% increase in heart attack, stroke, and premature death. So we're seeing a definite correlation here between the presence of the microplastics and very bad outcomes. And there have been a lot more studies since then. I'm actually just starting to read up on, we're looking for the mechanisms now. How does that happen? What happens with micro and nanoplastics and those chemicals in contact with vasculature? So we're looking and then it's not so good. But here's the next one, and clearly you've all heard about this one. This is the brain study. This is the Camden lab. They're in New Mexico. And the way that they did this study, this is Matthew Camden, he thinks outside the box a lot. And he was thinking, okay, well, we're not able to visualize a lot of this stuff because it is so small. We can orthogonally do it. We can sort of visualize this and this and this, but we need a more definitive mechanism. So he got brain samples, tissue samples from the morgue, from two different sets of decedents, people who had died in 2016 and people who had died in 2024. And they used the frontal cortex tissue, and they also had tissue from liver and kidney from the same people. And they dissolved that tissue in a solvent. And then they looked at what was left. There's a term for that, refractory, I was just looking it up. Anyway, they looked at what was left, and they analyzed it using what's called pyrolysis GCMS. So it's a long acronym, but what it means is they basically superheated what was left into a gas, and then they were able to analyze the gas for the chemical signature. And what they found was a lot of plastic everywhere, but mostly they found it in the brain. They found that microplastic was selectively accumulated in the brain, even more so than the liver and the kidney. Now, liver and kidney are filtration organs, so that's kind of where we expect to see the microplastics because the body is trying to get rid of them. The brain, not so much. They found other things too. This is an N of 12, so it is tiny, itty bitty, 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 but it sent a signal. They found that the brains of people who had a history of Alzheimer's or dementia had 5 to 10 times more plastic than everybody else. They also found that plastic was increasing in concentration over time. So, here's the 2016 group, and here's the 2024 group, and it's going up. And they thought, that's really interesting. 50%, this was not, just an incidental finding, 50% increase in the quantity of plastic. So then they started looking backward, and they got more tissue samples from other labs to see, well, is this happening elsewhere? And the answer is yes, it's going up over time. Why would that be happening? Camden's theory is toxic debt, that we've had so much of this plastic basically hanging around the planet now since about 1950, that there's enough of it fragmented down into nanoplastics at this point, that it's becoming more bioavailable because it takes time to go from micro to nanoplastic. So it's getting to a size now where it's capable of crossing into tissues. So that's the theory. And there are a lot of physicists working on the particle side of this equation who have been looking at the way in which plastic fragments down, and they are actually finding that it takes about 50 years for about 80% of the type of resins that are out there to fragment into the nanoplastics that they were able to visualize using other methodologies in the Camden study. So, all right, what are the effects? Well, we have two different ways of thinking about them, basically, two different sides of the ledger. On one side is the particles. What do the actual foreign bodies do when they get into the cells? And the other side is the chemicals. So what are they made out of? Phthalates, PFAS, brominated flame retardants. What do those things do? One way or another, it's the heat and the humidity. You're going to have a wet bulb no matter what. So in a sense, it doesn't matter. But of course, this is science. We want to know, and we especially want to be able to mitigate the effects. So knowing what you're looking at on either side of the ledger is still at least useful. Well, on the one side of the ledger, on particle effects, I think of this as kind of mechanical brute force. This is an external body. It shouldn't be there. Reactive oxidative stress got mentioned earlier today. So anytime you've got that particle and reactive oxidative stress next to it, which is what you get every time, you're going to have problems. That's most of what we see is chronic inflammation, damaging cell membranes, and so on. Now, inflammation can be from a lot of things, but it certainly happens when there are particles. And that's kind of what we know about particle effects, which gives us the other side of the ledger, which is the chemical effects, or what we call toxic trespass. What are these particles doing when they're in the body? Well, we take a step backward here to think about what do we already know? We know what they're made of. We know that 99% of plastic is made out of fossil carbon, so oil, fracked gas, what else is there? Coal, and chemicals. And so many chemicals that up to 50% of things like tires are actually just chemical filler. Well, what chemicals are there? Well, researchers have identified more than 16,000. And of those that they have identified, they know that 26% are hazardous. Now, hazardous in this case is carcinogenic, neurotoxic, so developing brains or grown-up brains, and also hormone disrupting. That's what hazardous means in this case. And this is not unsettled science. This is just, we know this, right? So not in dispute. Less than 1% are not hazardous, and that non-hazardous rating is incomplete evidence. And then over here, we've got 10,726 without any hazard data at all. These are the unknown unknowns or known unknowns. One way or another, they're very unknown, and they are what really worries a lot of the chemical researchers, because this is where the light is. This is where we've been able to study, but based on these proportions, it's not looking good for the other side of the pie. Well, here's the way to think about the way in which those chemicals are hanging out or moving around. Plastic itself has a carbon-carbon backbone, polymer backbone, carbon-carbon bonds. Now, I mostly stopped my chemistry study in sophomore year of high school, though I'm catching up now for obvious reasons. But even I remember that when you have a covalent bond, which is these, they're super strong. And that's why plastics don't break down, right? They're super duper duper strong, very hard to break. Then you have these chemical additives, and a lot of them, as I said, were highly toxic. Phthalates, bisphenols, PFAS, brominated flame retardants. Like what these all are is its own class, its own seminar, its own week-long intensive. And we don't need to do that right now, but we do know that these are pretty much on the do not eat list, right? Like if I came over and just dumped them on your plate, you should probably, move along. These, when they're added to the plastic, give it its properties. They make it pink, they make it flexible, they make it see-through, they make it look like a dream house, whatever it is, they're doing it, but they're just sitting inside the molecular structure. They're not bonded, which means that they can migrate out at any time in the plastic life cycle, and that's exactly what they do, chemical migration. And that is the center of plastics and human health harm right there, chemical migration. If you take one thing home from this lecture today, do not microwave anything edible in a plastic container. Because when it says microwave safe, it says, oh, steam this in a plastic bag. They are only talking about the container. They are not talking about the food. The added heat energy will enhance the migration of chemicals into food. Other things to watch out for are fat content. So a lot of these chemicals are lipophilic. They move into food. Also duration, that it's been standing on the shelf. Acidity, so things like ketchup or tomatoes, coffee, that sort of thing. All of those things are going to migrate. So okay, that's the take home. Plastic and food separate, forever to separate. So okay, well, what happens here? Also actually, microplastics also will break off more while you're microwaving. They get into the body and they hang out. We think of it as a Trojan horse model. So the plastic particles that are in the body, that are embedded in tissues and organs and moving around in the bloodstream, will be sending out those chemicals for as long as they're there. So it's a Trojan horse model of an environmental toxicant that's now sitting inside the body. And what's interesting for the researchers about that is that it actually makes what we already knew of as environmental toxicants more potent, because they're getting into places they wouldn't otherwise go. Like a plume or a spill is only going to go so far geographically. It's going to start to dissipate, but a microplastic is going to concentrate that and take it directly into the body. So what are we choosing to worry about? Right, our hair is on fire in so many ways. We all know this. All right, what's the part that we're focused on this? And it's the endocrine disrupting capacity of a lot of these chemicals that's the most concerning to the researchers. So the human endocrine system is the signaling system for everything. I was once at an intensive and the professor was asking like, well, name a organ that, produces, that's important endocrine wise, right? Like what produces hormones? And, people started naming them and I was like, dude, it's a trick question. They all do, all body parts are involved in the hormone system. So when you start changing things like insulin, you get differences all over the body. You get different metabolic effects. We like to think about the fun ones like testosterone and estrogen, but all of our body is regulated by hormones. And most of the chemicals that we really know about in plastics are capable of disrupting hormonal systems. And that leads to a cascade all over the body. So when you start reading about like, oh, the possible health impacts of microplastics, and it lists every single thing that's not an infectious disease, and you just glaze over, because like, how can it do that, right? Like that's a shyster right there. Like that can't possibly be true. The mechanism is the endocrine system. It is true. So the periods of greatest vulnerability here are going to be to those who are going through the greatest hormonal change, but specifically those people who are still laying down their bodies, their systems are still organizing. So fetuses, newborns, toddlers, of course we have plenty of other hormonal periods in life, adolescence, menopause, and so on, but those who are the most vulnerable are the youngest, who have the least to say about any of this. The timing makes the poison. Part of the reason for this, most of the reason for this, is that a fetus is, or a baby is not fully functional in repair. Their DNA repair mechanisms are not online yet. Their immune systems are not fully competent. They don't have the detoxifying enzymes that older bodies have. Liver metabolism, not yet online. Blood-brain barrier, not yet established. So what happens in the womb doesn't stay in the womb. And we know even the placenta studies are showing us great danger to fetuses. This is just one study, but it's really illustrative. Placentas from 43 pregnant women examined for microplastics. They found 13 pregnancies were complicated by fetal growth restriction, and that was highly correlated with the quantity of microplastic in the fetus. The more we study placentas, the more we find microplastics. And the more we do that, the more we're able to correlate those to damage to newborns, or damage that manifests later, but that was set during the newborn cycle, or during the fetal cycle. Fetal exposure impacts lifelong metabolic architecture. So you're programming your tissues during this period, your liver, your pancreas, your adipose tissue. This can mean, for instance, if you're exposed to lots of phthalates or lots of bisphenols, that child has propensity toward an increased body mass index, insulin resistance, type 2 diabetes risk. And this starts to explain why we're seeing such an uptick in many of these diseases, right along with the uptick in synthetic products in our environment, chemicals. This is a lab example. This was mice, female mice that were pregnant that were dosed 9 to 16 days of gestation with DES, which is diethylstilbestrol, which is a very, very powerful estrogen mimic. The mice that were dosed at 9 to 16 days of gestation, their offspring, given the same quantity of exercise and food, became far more obese than the control mice. Their metabolism had set at a different spot. And we see this over and over again in these kinds of animal studies. You know what, I had just too many slides on obesity. I was thinking about that a lot this month. But okay, so EDCs, phthalates, BPA, they're obesogens, they do the same thing in adults. The difference is in a fetus, it's permanent. In an adult, as you start to reduce your exposure, you actually start to reduce the lipid storage also. So we see that adults who manage to start moving away from some of the unnecessary exposures in plastics and so on, actually have an easier time dieting and getting a different weight profile. And here's the correlative graph. Now, correlation is not causation, right? We hear this over and over again. But at a certain point, the triangulation starts to get pretty clear. We have all these different ways of doing it. The one thing we can't do is start feeding plastics to individuals and then watching what happens as we dissect those bodies. But the correlations are very strong. And they're strong not just in the world of obesity and metabolism, but also in places like neurodevelopment. And that's another one where we really know that what happens in the womb doesn't stay in the womb. So we know that there's a massive increase in autism prevalence. And some of this, yes, is about recategorization, changes in the definition of autism spectrum disorder. So now things like Asperger's and ASD, they're on the same spectrum. But this far exceeds what can be accounted for from diagnostic changes. And it coincides also with an uptick in ADHD and similar disorders. The reason that we're thinking that we're seeing this has to do with the way that brains develop while in the womb. You have a lot of cells that are moving very quickly and differentiating into neurons, and they're moving into different places. This is a schematic of the New York City subway system, which can give anybody a headache. But the idea is to think about track being laid down, right? Your neurodevelopment in the womb, all of those neurons are migrating, they're setting themselves down, and they're setting very specific connections. And it happens incredibly quickly. It's exquisite, but it's also an exquisite vulnerability. So if those connections don't get made, and let's see, we've got the one train here not intersecting where it should with, say, the A train, you got a lot of stranded commuters or slow commuters. And that's basically the metaphor for neurodevelopmental disorders. Not necessarily insurmountable, but causing an awful lot of traffic that never needed to be there in the first place, especially considering how much of this exposure was completely unnecessary because it was tied up with things like single-use plastics, things we never needed in the first place, but that were introduced to us by markets and remain with us. This is the general graph of non-communicable diseases going up and up. And this is really, again, where the thinking is with chemical exposures. So a lot of it is plastic. It's not all plastic, but hey, 70% of this is going into plastic. So that's why I focus my attention here. This is really where I can see a spot on the hydra that will affect the entire hydra as we look at it. As we start to think, this is petrochemistry at work in our bodies. So this is all incredibly stressful. I should have had some like relaxation kittens much earlier in the presentation. I think I did before, but they got cut for time. That always happens, right? So, okay, take a breath, let it out. Remember I said I wouldn't be doing this if I didn't think there was hope, right? Like I may be a sadist telling you all this horrifying information, but I think there's hope, and that's why I can do this every day. We'll get to the hope shortly. Here's some confusion though ahead of the hope. Some of you might have seen this article in The Guardian. It came out in January. It was not an investigator, it was a journalist who interviewed some scientists, one of whom was from Dow, who said, there's some doubt in the science here. I think that the told the Guardian of their concern that the race to publish research results, in some cases by groups with limited analytical expertise, led to rushed results and routine scientific checks sometimes being overlooked, raising questions of what is really known today and how concerned people should be about microplastics in their bodies. Well, yeah, new analytical techniques, because this is a new science. There's a race to research because it's incredibly critical. Doesn't necessarily mean though that the field is contaminated. But of course, an article like this is really what you want to hear if you're hoping that some of this is not true. And of course, it's also going to get picked up lickety split. So it did. So because of this article, there's now a lot of controversy around microplastic science. And a lot of it is steering into one place, which is representatives from Dow, from Amazon, saying things like, well, we don't really know anything about particle science. Therefore, we don't know anything about microplastics and harm. But remember, particle science is only half the ledger. They're erasing one half with the other half. So, all right, the main criticism in this, because you're going to hear about this every time now you open anything that has to do with microplastics research, you're going to hear that it's controversial. The controversy in this was in that one methodology in the Camden lab, pyrolysis GCMS, where in that signature that they're looking for different plastics, in the gas chromatography, lipids can look like polyethylene in that. So yes, that is a potential problem. The Camden lab knew it, they controlled for it. All the other labs that are using the same methodology are also controlling for it, but it is a possible point of confusion. I'm going to point this out. This is from the Camden paper, though. These are the different resins that they found. Now, they did find more polyethylene than anything else, which wasn't a surprise because a great deal of the plastic that exists out there is polyethylene. That's numbers 1 and 2 and a few others. It's mixed in with a lot of plastics. But hashtag not all plastic resins are polyethylene. There's still a lot of microplastic in the human body, and it's going up. So that doesn't change. Like I said, it's consistent over time. So reports of the death of microplastics research were really premature. We know it's there. The real question is how much is there and what is it doing? But we absolutely know it's there. And I feel the need to point this out, especially in our current political climate. This is stuff we've seen before. The creation, the manufacture of doubt, because we've seen it all in climate science, right? Oh, that one person over there doesn't agree with 90% of everybody else in the room, therefore the whole science is in doubt. Now, the guy in the Guardian, that article, he cited 7 studies that he said were questioned by other scientists. Well, first of all, we all know that scientists question each other all the time. That's called science. Thank you, yay. But that was the numerator, was 7. The denominator is tens of thousands. So we have a very similar thing happening here, where the small disagreements inside of the science are being used to cast doubt in the public literature. Also, who said this? Oh, look, it's our favorite Dow scientist right here, Roger Coleman, who said, it's really forcing us to reevaluate everything we think we know about microplastics in the body. Thank you, Dow. Excellent. Moving right along. So why is this happening now? This is a historian's question. And this is really the one that we use to try to figure out how to solve the problems that we have. Why now? Well, why are we seeing more plastic in the brain? That might be because of physics. But why are we seeing so much plastic, period? And why is it being defended tooth and nail, even though we know how widespread the harms can be and to whom they affect? Who do they affect? They affect the children, the babies, the future generations, and any of us who have an endocrine system, which might be most of us. Here's the counterintuitive thing. A lot of it has to do with the climate crisis. Now, we all know what's happening. We spent the day talking about ways in which it's happening and what it's doing. That's bad. There's one silver lining, and that is that those who are paying attention and have the financial capacity to do so are moving over to renewable energy very fast. Last year, according to Bill McKibben, more than 90% of the new energy installed globally was renewable energy. And you can also think about it again historically. It took a long time to move over from wood to coal, coal to oil, oil to renewable. So it couldn't happen overnight, but it is happening. We need it to happen faster, but it's happening. It's happening. Yay! Who is that bad news for? Oh, right. If you happen to be a fossil fuel producer, you might not like what that looks like for your margin. And frankly, these guys are the smartest ones in the room. They always have been. They're very well paid. They've been planning for this. And this is not a secret or a conspiracy theory. This is set out in the earnings calls, in the projections, in the financial sheets of the fossil fuel industry. That as we stop using fossil carbon for fuel, they'll need to pivot the market. And a great place to put fossil carbon is plastic. So it's plan B, not a secret at all. British Petroleum expects plastic to account for more than 95% of growth in oil demand moving forward. And it already is. It's moving up and up and up. A lot of our energy has moved over already to fracked gas, but oil can make plastic. Actually, ethane, which is fracked gas, also does. And this is where it's circular because plastic production is itself a climate problem. Plastic's responsible for 5 to 10% of all the greenhouse gas emissions right now. By 2050, it could exceed 20%. If plastic were a country, it would be the world's 5th largest greenhouse gas emitter, just ahead of Brazil. So this is a significant portion of the pie. There is a lot at stake here. And this is a $1 trillion industry that is defending its profit margins. Now, if we don't grow at all from where we are on manufacturing plastics, we're still just barely gonna meet the climate goals. But if we continue to grow, we will shoot right past any kind of climate goal that is set to try to bring climate change, global warming down below 3 or 4 degrees by the end of this century. So this is not something that we can afford to look away from. Decarbonizing the power grid entirely won't be enough to reach our climate goals if we keep producing plastics as we do now. So how do we solve this? We can, I'm still here. I haven't changed professions yet, and I don't intend to, because I really do think we can solve this. First of all, as a clinician, there are plenty of things that you can do to draw patient awareness to this that seeds things, right? We've talked about that, we've heard that in our communications discussions already, seeding things. So some people are already asking, during my lectures, people ask all the time, like, why didn't my doctor tell me not to microwave things in plastic? Well, go ahead, spread the word. Tell people not to microwave things in plastic, to get rid of the plastic kitchen utensils. If it's plastic, there should be an ick factor here. You don't eat off of lead plates. You shouldn't be eating off of plastic ones either, for the same reasons. So toss the Teflon, that's PFAS, that's plastic. Things that are standing around in the pantry, decant them into glass. Try to buy the glass, that's cost prohibitive for almost everybody, but jars, empty jars, not cost prohibitive at all. I have too many in my recycling all the time. So decant things. Infant care. This is harder. If you've had a baby in the last, say, 30 years, its whole world is plastic. But places that it's possible to start, or at least to notice, are things like changing pads, fluffy carpets, and especially baby bottles. Now, plastic and baby bottles go hand in hand because they don't break. But you can buy glass ones that are surrounded by sort of a rubber thing. Again, this is a little pie in the sky, right? Because these are all price points that most people are not going to go for. It's going to take a lot of persuading. I can say I have colleagues in England who are working on the NHS to stop sending home plastic baby bottles with new mothers and putting in glass ones instead. And that's actually right on the point of happening. So it can happen, it will happen. It sends a message when you think about what babies are putting in their mouths and living on. And then things like textiles. Think about your exposure. So the sheets that you're sleeping on, the polymers that you're working out in, 70% of our clothes have synthetic polymers in them. So you can't avoid this stuff. That's not your fault. But you can try to still, the places that you can, cotton sheets, do it. Wall-to-wall carpeting, most of that is synthetic. Rethink that next time, you're doing your decorating. And, when you're going hiking, when you're doing your exercising, dude, does it feel like a rubber band? It probably is. If you have a cotton alternative, we know cotton kills when you're out there hiking, getting wet and that sort of thing. But those are kinds of fabrics that as you sweat into them, they leach right back into you. So think about that. This is the #1 recommendation, and I put it in here because it's insane, which is a reverse osmosis water filter. Once you start thinking about environmental contaminants, the way to deal with that in your house is water filters. Well, a countertop one is kind of expensive, and under the sink one, which is more effective, is more expensive, and the whole house system, which is really what you want, because when you're showering, you've got steamy water moving back and forth in your pores, you don't want PFAS there. That's ridiculously expensive. So right here, right now, we're starting to think already like, hey, maybe these individual solutions are not going to work. They help, they give us a sense of power where we can use them, and they certainly make you feel more sane. When you've got your metal water bottle, you just feel like you've done something. But we all know that regulatory systems are the most efficient and the most just for everybody. We're not in a climate where that's particularly possible at the moment, but we do have this going on our side, which is that everybody hates microplastics. Everybody, globally, frankly. I heard actually from a guy who reports directly to Jeff Bezos that the number in the United States is 90% of people dislike microplastics and they want them out of their water and their food and their air. So that's pretty strong as far as consumers got the picture. Again, this is not a consumer problem. We did not ask for all of this. We're asking for alternatives. So don't let anybody ever say to you, oh yeah, the problem here is consumers, they just need to be educated. They're educated. Consumers need to find a way to get their voices heard, And that's gonna be the next project for the next few years, but remember, people agree with you. If you're worried about this, people agree with you. They particularly agree with the healthcare practitioners. Concern about plastic skews more toward human health than it ever did toward sea turtles, toward the environment. So that's sad in its own way, but I prefer to look at it as a moment of empowerment. My own theory of change in all of this, as people are thinking more and more about the health impacts of plastics and what that means for them and how much they don't want microplastics in their bodies, this gives us an opportunity as clinicians, as medicine people. Where can we push? We can talk to patients, we can talk to lawmakers. The number one thing that we can do though is our own medical societies. Because most of the time the medical societies aren't paying a lot of attention to this yet. They may say, oh, there's not actually enough data. There is enough data. We have already met the Hill and Dahl criteria on the chemical side. Particle side, no, but that's somebody's doing. They're making that argument. That argument didn't come out of the passive voice. Somebody is prioritizing that side of the ledger. We have the data. As we bring our medical societies up to speed, as we introduce an ick factor of plastics as a hazardous material in medicine, just as we did with lead, but even more so as we did with germs. Right? Once people could see germs under a microscope, they started to be more concerned than they ever had been. After Koch started photographing germs, tuberculosis, bacillus, and so on, seeing was believing, medicine and everybody else followed. So as medical societies understand that plastic is hazardous, regulation will follow from there. That's my theory of change, and that's what I'm running PSNAP for. We also know that people actually prefer politicians who take action on climate, but though the politicians don't necessarily say that themselves. So a place that you can join in the fight if you're feeling energized, or even if you're not, frankly, it's been a long day and there's been a lot of really heavy material. But if you want to stay in the room with the people who understand the heavy material, who are thinking about this stuff all the time and talking to each other and having community with each other, contact me afterward, psnap.org. This is where we're bringing the clinicians of all stripes together and also the researchers as we're sending people out to talk to the regulators, talk to the medical societies, talk to each other, develop patient materials, send in op-eds, just get loud because your voice really matters in this fight. So thank you very much for your attention. I know it's the end of a long day. I'm the last speaker, but you're still awake and you're taking pictures. That's awesome. So I think we can take questions now. Okay. Just a minute. I will hand over questions. Okay, great. That was fabulous. Thank you so much. Really inspiring and hopefully not too alarming. On the other hand, if that helps people stay awake in the afternoon, that's not all bad. So questions. We have about 15 minutes for questions and then we'll have wrap up. So go for it. Sure.
Just a quick one, Megan, you want to explain to people why compostable plastic is good?
Oh God, okay, why is compostable plastic not so good? Because in order to make a sugar, like compostable plastic is usually bioplastic. So in order to make it act like plastic, you still have to add that whole suite of chemicals. Sometimes they're slightly different, but at the end of the day, you're still looking at a product that when you put it in your compost pile, it's going to contaminate your compost. It's also not regulated, so there's no definition of what compostable versus bio-based plastic means. And in a lot of cases, the manufacturers will actually add just regular standard plastic in order to make your fork act like a fork. They're not required to report that they did that. So it's basically, it's what do we call it, a false solution, right? It's a, like, we really wanted to try, and maybe someday we'll get there, but we're not there yet, the compostable plastics. Oh, no.
Wow, really wonderful. So the things I should be unhappy about.
Everything, everywhere.
Climate. Ocean acidification. Biodiversity. and now plastics. But what I take from your talk is that any effort that we can make to reduce our exposure on plastics will have a faster effect on human or ecosystem health. Is that correct?
I'd say that that's mostly correct. I guess the like, what does faster mean, right? Like, I really like Rob's comment about like, if we stop putting out CO2, it'll take a long time for the climate to change, but our health changes in hours. So yeah, we reduce our exposures, our direct exposures, because it's so much in the food chain and so much in our very direct world. That does have a pretty fast impact on us. In the world of like, okay, we should be upset about everything all the time, and maybe we should just all go drinking now, and like, there was an Onion article a while back about a climate panel that just stopped in the middle of the panel and went drinking. They were like, forget it, everybody. It's all the same hydra, right? It's the same hydra. It's coming from overproduction and overuse of fossil carbon. And I like plastic because people can see it. You don't get plastic pollution deniers. It's really tangible to people. And once they start thinking about like, whoa, well, there's microplastic in me, what's that doing? And then I start saying, oh, it's chemicals and it's PFAS. And people who fell asleep like 2 years ago, stay awake now. It's like, come for the microplastics and stay for the endocrine disruption. So it's an incredible like wedge to get people listening to what we've been saying for decades. It's kind of an opportunity. So that's why I look at it that way.
I have to crack the joke that we should be careful that there's no microplastic deniers yet.
Yeah, I know, it's all dark humor. There was a spot on like the Daily Show where it was another false solution. The plastics industry and the manufacturers had decided to start adding vitamins to plastics so that when they become microplastics, they're full of vitamins. So they're healthy microplastics and they're good for you.
I had a question about those little plastic bags that you get at the co-op or food co-ops to put your mushrooms in. Are those, and you put your compost in and put them in
No.
they're bad.
Bioplastics. I will say, in the world of like, maybe we're partway there. Oh gosh, what is it? I'm not supposed to name things by brand name because then like I can get sued by industry, but stasher bags, right? What are they made out of? They're made out of nobody recognizes this brand. Silicone, thank you, silicone. So silicone is still a plastic, but it's far more inert than all those other plastics. So that stuff is great. Don't nuke your food in it, but you're actually much better off with that. But in general, like paper wasn't such a bad option, jars break. But the thing to think about with plastics, all plastics, they are not inert. We were taught that they were. They're not. They're stable, but they're not inert. And so they are, migrating their contents into our food at every stage. That's the problem. Yeah, I don't know who they study first. We'll start here everybody. Yeah.
Thank you so much for your talk. Thanks for coming to this conference. I got two questions. You just referenced Rob's comment on, what happens to the human system once an exposure is gone for a short period of time. But do we know what happens to the human system when a plastics exposure is gone? And kind of part B of that question, is the science headed in a direction of trying to pull plastic out of the human? Is there active research into that possibility?
Yeah, okay, so when is plastic exposure gone? I ask a lot of time, like, when does plastic stop being plastic, right? Like, when all the PFAS is migrated out, are we still, like, are we out of the water yet, out of the woods? The answer, unfortunately, is that our exposures are so ubiquitous that even as plastic ages and may have fewer additives in it, you're still just taking on more plastic. So it's not that easy to not be exposed. The easiest ways are through the things that we can control, which would involve things like food. So the Camden lab actually, because they're able to dissolve tissue, they like go out and buy hams and like, they've been looking at lots of other animals too. And they found that there's more microplastic in meat than there is in vegetables, we think. They're having trouble digesting cellulose, but more in meat and processed meat. So things that are processed are gonna have more chemicals anyway, but more microplastics also, you can reduce exposure there. Okay, in terms of removing plastic from the human body, I think the term is apheresis, right? When you filter blood and you filter out contaminants from blood. Unfortunately, think about what you're filtering through when you do that, right? You've got IV lines. Those are made of polyvinyl chloride being a carcinogen. So you're not really ahead of the game. Also, there's a lot of DEHP there, a plasticizer, which if you want to look that up, that's a really fun night of reading. So apheresis is not a very good way to go. There's a lot of snake oil out there. A lot of supplements that are coming out that people are saying, oh, this will bind to the plastic in your body and you'll excrete it. Your body is really good at getting rid of what's not supposed to be in it. That's why we have livers and kidneys and, even our brains, like there is a lymphatic system that moves things through the brain. We don't really have an external solution to this one yet. It won't surprise me if we do get one, but it's not there yet. So don't run out to the nearest clinic that's going to offer to cleanse you of microplastics. Yeah.
Could you say, what is the best way to dispose of plastics?
Oh, that's a good question. What is the best way to dispose of plastics? You get different answers from almost every expert. Matt Campen actually wants to burn it. I'm not with him there. I think actually a sanitary landfill, because those tend to be the most inert. We're just kicking the can down the road there, but if you're interested, there's actually a whole field of study about garbology, they call it. And it turns out that if you go into an old landfill and you start drilling or digging down, you can find newspapers from the 1940s that are still readable because there's not a lot of oxygen there. So that's where it's just gonna get entombed. And that's the safest place for it for now.
There were there's just so many good questions, everyone's.
No, I have a bunch of questions. Do you, know about Ridwell? You heard of this?
Ridwell, yeah.
I claim to recycle all the stuff that no one else will.
Yeah, they're not recycling it. I haven't done a dive on Ridwell yet, but its predecessor was, I think, the Glad bags or the Hefty bags. And they were going straight into incineration. And there was a parallel program too, where Crayola was pretending to recycle markers. They were getting, I can't believe this, I'm so angry. They were having Girl Scout troops collect used markers for recycling, but they were actually just incinerating them. And they were calling that waste to energy recycling. So that's what most of these plastics recycling scams are. They're scams. The only resin codes that are recyclable at all are 1s and 2s and sometimes 5s. But you already have a toxic product and now you recycle it into an even more toxic product. So not an awesome solution there. Most of what happens to the others is they wind up in cement kilns, or they go into, and this is a whole other seminar, what they like to call chemical recycling, which is basically just a toxic degradation of the molecular structures of plastic into some really dirty fuels and a lot of byproducts, and it uses an enormous amount of energy to do it. But it makes it go away, and if you can argue that it's going away and you're a super big company and you want to keep producing more, then you're going to put a lot of money